So I just really quickly want to juxtapose a couple of things that you'll see in the text that maybe aren't supported in a way that I think kind of lends to good programming design. Here in the pre versus post increment example, we are using a for loop, right? So I'm just going to scroll down here to line 35 through 38. We're using a for loop. Here inside of the for loop, I am using essentially an inline definition for the value of I, and that I again is my increment, right? So I am setting I to 0. I'm saying I less than 10 and I plus plus. Here's the problem. What does I really mean? I mean, you know, and I know because you've already listened to the previous podcast here that I is for increment. I'm going to increment so many times, but the next developer in the chain may have questions. Like, for example, why this many times? Right? I haven't given any indication as to why I equals 0 or why I less than 10. That's not good programming design because the next developer in the chain might not have access to why it is that I equals 0 or is less than 10. What happens if the number of increments we need is going to change? Now what? The next developer in the chain has to know every for loop that is being used with an increment counter that is set to whatever our need is. So in other words, the next developer in the chain has to know, okay, here on line 35 and here on line 44, so this is already just two instances, I'm going to have to know as the next developer in the chain, oh, we really meant 12. I need this to show up 12 times because really we're doing it once a month or once every 2 hours or once an hour, but this is going to run twice or whatever the case might be, right? So even here, just inside of this 50 lines of code, I had to change 2 lines, right? Lines 44 and 36 to reflect the fact that my iterations, the number of times it is I'm engaging in these for loops, has changed. This is a problem because you are never guaranteed as the next developer in the chain that you are going to have full and open access to the program here as a whole. Much better. So again, this is the known for loop. I just needed to give it a name for you guys. That's the second window here. Is to use a constant integer for your minimum number and your maximum number. And this way, when you're building your for loops, just like we did here on lines 15 and 16, when you're building your for loops, I can say, num equals, so I've already declared my int num, although I could really do that right here inside of, I could really do that here inside of my for loop and it would be okay too. My suggestion to you here is don't use the same variable name here on line 10 or here on line 15, but I'm going to go through here, where you go, and undo that so you have the same code in front of you as I'm using here. So here I've got num, and num is the variable that I'm using to help this for loop iterate and sooner or later become false so that we can leave out of this for loop. Next, num is equal to minimum number. You'll see up here on line 8, I have a constant int min number, and that's equal to 1. My second argument, num is less than or equal to max number. Here on line number 1, I have my ending value with max number set to 10. This way, if rather than using, those discrete i's, the declaration of a new integer called I in each of my for statements, I can use this constant int because that's going to have meaning outside of just this one particular for statement. Next, so let's just go ahead and run this and prove that it works. So this did work. So min number having been declared here on line 8 and max number having been declared here on 9 do actually help me maintain the state of this particular for loop. Now, before we get out of here and say, yes, very good, I can use a constant to help me maintain the state of a for loop, full stop, right? Hold on a second. You'll notice on line 15, that is my loop instantiation statement. I have created a loop here. On line 16, I simply have my cout statement, but I haven't wrapped this in a code block with curly braces. What I will tell you is this is bad programming form. Even when, so the text has one or two examples of, hey, look, I've just got a for statement with one simple piece of either math or one simple output there to be made. It is true that as part of the default rule set for C++, the line following a for statement by necessity belongs to that for statement. And what I can tell you is don't do that. What I would tell you, replace that rule with a much better programming practice rule is the lines following a for statement must include an opening and a closing curly bracket, because what happens if I come through here later on to try and add some kind of new display or to add some kind of new math, like if I want to take my number squared and add it to a running total. If I was to simply undo these two lines, so there we go, back to the original. If I was to create an int called total, and that equals num times num, just like so. What this line is saying is I want a new integer declared that's going to equal the value of num, which in this case starts at 1, and it iterates all the way up to max number here, which is 10, right? So what I'm hoping to do is add 1 plus 4 plus 9 plus 16 plus 25 ... plus 100. So if I'm to run this, let's also do this. Let's create a cout and let's just do total. Like so. It's not entirely pretty, but it'll do. So let's go ahead and run this. 121. Is that the number we expected? My suggestion to you is no, in no way, shape, or form is that the number we expected. And actually, I can tell you a little bit more about why that number is so strange. Did I ever allocate the space over here for what total started out as? No. So 121 is not 81 plus 100. Num times num, turns out number is 10 here. Where did that extra 21 come from? So at any rate, what I'm trying to tell you is this is not good code design. Much better than this is to add the code blocks here. I'm on two different tables trying to type these out. It's taking me a second to adjust. There we go. Much better would be to wrap this in a code block, so that way you can be assured that the loop here, so from lines 15 to 19, is including all of your lines. That's line number 18 right here of logic, as opposed to just the line that follows your for statement. So constant integers, very good idea when it comes to managing, maintaining, and giving a little bit of additional value to the next developer in the chain when it comes to how are we maintaining our counted for loops.